Okay, welcome to this performance chart webinar. We are going to be talking about compressor performance charts as a technician. Someone just need to mute themselves there. Maybe that's Gary. Yeah, so we're going to talk about today about compressor performance charts. And I was a technician in the field, and we'll get into that in a little bit. And I didn't know much about performance charts, and I didn't use them in the field. And why I want to talk about them today, because it can be a valuable tool as a technician in the field. And I know there's some instructors on here. You can use this as a tool to train apprentices and technicians, because it's important to really have a full grasp of compressors. So a little bit about me. My name is Trevor Matthews, and I work for a company called Refrigeration Mentor. And what Refrigeration Mentor is a global training and education company talking about commercial refrigeration, everything in and out of refrigeration. And I started my company 3 months ago, and it's been very exciting and very good because I have so many people interested in training, and I'm really happy that I get the opportunity to share my knowledge with you, technicians, instructors, people that want to learn about refrigeration. A lot of people ask me, like, what's the programs I offer? So I got 3 programs here that I'm offering right now, just to give you a heads up. We'll talk about it in a little bit because I don't usually do this. So I do a service and troubleshooting compressor masterclass. I do a supermarket refrigeration learning program and CO2 learning program. And for those who don't know me, I've been in the industry since 2004 as a technician in the field doing commercial refrigeration in Canada as well as in Australia, and a lot of different background in commercial refrigeration, as well as a gas license, lots of different trainings that I've been through. And before I started my own company, I worked with a company called Emerson or Copeland Compressors, and I was the lead trainer for them across Canada. And I've trained thousands of technicians, manufacturers, distributors. And like I said, 3 months ago, I started my own business to help technicians and organizations, contractors with commercial refrigeration, really to get better, to get more confidence, more efficient, and more effective when they're servicing, troubleshooting, and installing systems. That's a little bit of my spiel, and we'll get into it now. So today, what we're going to be talking about today is, here's the agenda. We're going to be talking about compressor performance chart. We're going to review key terms and definitions of these performance charts. I'm going to talk about where to find them, because I didn't even know before I worked for a compressor manufacturer. I didn't even know about them, to be honest with you. I may have learned about them in school, but that was a long time before I went back into any training. And after working for the manufacturer and then researching all the other compressor manufacturers, like all the big ones, I started to notice that, wow, these compressors that I'm working on, that I'm servicing, have manuals, have charts, have all these different things that as a technician, I just didn't really think of and didn't use on my daily basis. And so we're going to get into that. We're going to talk about how to use the performance chart as a technician or as an instructor or as a lead journeyman or lead technician to show apprentices how to use them. And we're going to discuss, I got a troubleshooting scenario or two that we're going to talk about, and how you can use the performance chart. If you have questions at any time, you can either raise your hand or unmute yourself and say, hey, Trevor, I got a question. This is very informal training, just to really help you out and get you some information. So first things first, I'm pretty sure I do have a polling question here. Let me see, I'm going to launch one anyway. So the first one is, you should see it come up. Have you ever used a compressor performance chart before? So just click yes or no. Have you used one? Have you seen one before? I kind of want to get an idea of if anybody has seen one or used one before. I'll just give another 20 seconds here. So it's pretty close. It's almost 50-50. for the people on here. So that's pretty good. I'm kind of surprised there's that many people have used them before. So excellent. That's really good. Okay. So I'm going to just even share the results with you so you can see. So 9 said yes, they've used it before. 10 said no. So I'll stop sharing that. Let me pull this down. So we're going to get into the key terms and some of the key terms here. So Imperial. So this is what we use here in North America. In Canada, we kind of use both. And you'll start even seeing in the US, there's a little bit of both. And I'll talk about the metric one in a minute, SI unit. It's very important to understand both. You know, I know that here in Canada, here in the US, or North America, we got people from all over the world here, is that we use Fahrenheit, PSI, BTUs per hour. But there's new technology that continues to come to North America, like CO2 refrigeration, and you'll see if it comes from Europe, it's going to be in Celsius, bar, and usually kilowatt or watt. And it's important to understand that because you do need to understand the conversions when you're, you know, over time, as you become more skilled at the refrigeration trade, you should understand how to do those conversions, Celsius to Fahrenheit, Fahrenheit to Celsius. You'll learn this in basic usually, but over time, if you don't use it all the time, you forget about it. So I always have a performance calculator, a units calculator that will change either pressure, lengths, temperature, because I work with a lot of different people and we talk in different terms. So it's so important when you're talking to someone, you're on the same page. That's very important because if you say minus 20, well, it's minus 20 Fahrenheit or minus 20 Celsius, depending on who you're talking to. It's kind of like talking about temperature difference as well as TD. TD can mean a lot of different things, right? So it's important to understand what you're talking about. Chris, yes, it's being recorded. Hey, Manuel, how you doing, brother? So next, SI, metric. So that's Celsius, bar, and watts. So it's just important to know the differences because when you're using performance chart, depending on the ones you're using, you may have to go into the software and change them to the one that you prefer because you do have to do the conversions in your head and make sure you understand those. So we'll get into this here. So for capacity, we talk about BTUs per hour or 1 watt. So 3.412 BTUs per hour equals 1 watt. Okay, something that you need to understand and should understand as a technician. Compressor cooling capacity. Okay, and I should talk about BTU first. So for those that don't know, BTU is the measurement of heat contained in an energy source. So it's really the quantity of heat to raise 1 pound of water 1 degree Fahrenheit. And so that's called the British thermal unit. Okay, so I didn't mention that first. And compressor cooling capacity. So this is something that you need to understand as well. So this is the amount of cooling the compressor itself can do. So it's the product of the evaporator enthalpy rise and the compressor mass flow. So each compressor, depending on the size of the compressor, depending on the refrigerant that's in the compressor, will have a different cooling capacity. So that's very important to know because a compressor, say, could do 12,000 BTUs with one refrigerant, may not do 12,000 BTUs with another refrigerant, or just say 1 kilowatt with one refrigerant may not be 1 kilowatt with that other refrigerant. So you have different capacities with different refrigerants. Very important. And you'll see this on the compressor performance charts because you need to make sure you pick the right refrigerant or that performance chart's going to be different. Okay. Next is evaporator capacity. So what this is the net refrigeration effect. And this can be different than the compressor cooling capacity. And this is really important to know because really the net refrigeration effect is the heat that each pound of refrigerant can absorb in that space. So it's the amount of that refrigerant going through that evaporator and each pound of that refrigerant is absorbing that heat in that space. So that's your net refrigeration effect. And on the performance charts and the softwares that we'll look at today, you're going to see that that can be different. The compressor cooling capacity can be different than the evaporator capacity. So it's very important to understand that as well. Next, we have power input. And really, power input is the power consumed or used by that compressor. So depending on the condition, you're going to use different amounts of power. And this is important to know because the only way to tell if a compressor is running efficiently is by getting the pressure, the temperature, the volts, and the amps. And then you need to plot it on the electrical curve chart or these performance charts that I'm going to show you today. Because if you don't, then you just say you're using the RLA off the side of the compressor. That is not an accurate measurement. So you need to actually go into these performance charts to see if your compressor is running and performing efficiently. So I see some new people joined. If you do have any questions, you can throw them in the comments box or in the chat. And if I missed any, we'll get to them. Current. So current is the measure of electromagnetic force. So it's really that electrical that can be conducted through the wire. So the currents, when you take your amp clamp, the compressor is running and you put it on L1, L2, or L3, or C, or T1, T2, T3, depending on the compressor, to check your amps. So what that compressor is running at those specific conditions. So it's important to understand that. You'll see that on the performance chart. Mass flow. So this is very interesting. Mass flow is the amount of refrigerant traveling through that system. And you're going to have a different amount of mass flow depending on a few different things. The conditions that system's running at, the density, so how cool that is, the pressure. If there's a pressure drop, it's gonna change that. So, like for example, if you have an increase in return gas temperature, it decreases the density, which decreases the mass flow. And mass flow is the way it travels through the system. So that can affect what is going on, especially when you're doing a service call. To understand that, because if you're not meeting the box temperature or that load temperature, well, it could have something to do with the return gas temperature, which is affecting the mass flow of that refrigerant traveling through the system. And the density of it is on temperature and pressure. And we'll get into that a little bit more. So that return gas temperature, some people will call it the suction gas temperature. It's really that temperature at the inlet of the compressor. So at that suction service valve, that inlet, we call that the return gas or the suction gas temperature. And this affects the mass flow. It affects the efficiency of the compressor. It even can affect a bit of the capacity. And we'll look at that as well. Because if you have a really high return gas temperature, well, there could be something going on in the system causing that. And now you could be potentially causing overheat, not maintaining temperature in that box or that case. And it's important to understand. And we'll dive a little bit deeper into that. And then we'll talk about EER, so energy efficiency ratio. And that's really the output of cooling energy versus the energy it's to operate, and at the operating point, the energy it takes. So it's a few things that's going to be on there. We'll go over these again because I know there's a few people new here. But it's important to understand these different key terms when we're talking about performance charts and compressors, because you're going to see something similar on all the different performance charts that we'll be going through. So I do have another polling question here that I'm just going to pop up here. And Compressor Brands. So I just launched it here. So this is a multiple compressor. You can select a lot of different ones here if you work on a lot of different ones. So what compressor brands do you install and service? I kind of want to get an idea of what compressors you're working on right now in the field or that you're learning about. And like I said, you can pick multiple ones. I'll give another 20 seconds. So a variety of compressors. That's fantastic. And it helps me be a bit relevant for the training too. So, okay, fantastic. I'm going to end poll. I'll share it with everyone, share the results so you can see it. So we have Copeland, then Tecumseh, then BITZER and Carlisle. Okay, so fantastic. Thank you. Okay, let's keep going. So breaking down the compressor performance chart. So this is a performance chart of a Copeland compressor. And this is out of the Emerson PSS software, product selection software. So this is something you can download for free and get on your computer if you want. It's also in the app called COPO Mobile. I highly recommend having that one as well. And this is what it looks like. You know, this is a performance chart of this specific compressor. So if you see my here, this is a 6DC3F 93KE TSE. It's very important to have the exact model number. And same with putting the proper voltage and hertz, because that's going to affect the performance chart itself. Okay, over here's the rated conditions. 65 return gas, 0 subcool, 95 ambient over. So when you go in there, you can actually adjust these things for these rated conditions, which will change the performance chart, which will change the system dynamics when it's running. See a question in your manual. Is the density of the saturated refrigerant much different from that of the superheat refrigerant? Does the situation of effect on mass flow rate through the system? Yes, it does. So the cooler the gas, what is it again? I'm getting a brain for it. The cooler the gas, the more dense it is and the more mass flow you will have. But if you have a higher return gas temperature, so higher superheat, you have less density, less mass flow. Hopefully that makes sense, Manuel. So it definitely changed. And we'll talk about that here in a second, and I'll show you a little bit about that, Manuel. So this is the rated condition here. This is a low temp application, and you really want to look at these because I see a lot of gas retrofits happening right now going out of, because we're in a time where regulations are changing. We're going from HFC refrigerant to either natural or to HFO refrigerants like 448, 449, 513. And that means that if you're doing a gas retrofit, that there's chemically difference between the refrigerants. So some refrigerants are going to run hotter, and it's going to put them in a zone where you need extra cooling. Like here, this blue zone means it needs demand cooling. And this is for a Copeland compressor. But if we looked at a BITZER or a Bach or Carlisle, they're going to have a similar thing where they're going to say you need a head cooling fan, you need injection. And that's why it's important to look at these performance charts, because you could be running the compressor in a zone where you need extra cooling. Okay, so on the top here, this is the evaporator temperature at dew point. So this is a 2-point pressure. So you have bubble point and dew point, but compressors here, I have here is on the dew point pressure. It can be changed in the software, product selection software. And you can see here's the temperature. So this is, I'm in Fahrenheit and PSI right now. And in brackets, that's the pressure. Really the saturated pressure, 9 PSI. So minus 20 and 9. On this side, this is the condensing temperature. So we have a temperature 120 Fahrenheit, 110 Fahrenheit, 100. These could be in Celsius if you converted it in the software. And then here's the pressure, 210. So that would be the pressure. So if you have your gauges on a compressor, for example, at minus 20 and 100, this is the zone you would be. You'd be running at 9 PSI and 210 PSI. So you'd be right here at this zone right here. Okay. And it's good to understand that because there's a lot of things that you need to see. On the side here, C stands for capacity. I talked about that earlier. a little bit. So that's your BTU per hour. P is for your power, so that's your watts. A is for your amps. M is for your mass flow, which is right here. E is for your EER. And this percent size isotropic efficiency. I'm not going to get into that. That's really more for engineers. And even at that point, I don't think you'd use that as much. But as a technician, to understand, you would need to understand the capacity of the compressor. As you can see, at minus 40 and 100, this compressor will do 41,000 BTUs, 41,000 BTUs in capacity. But at 0 degrees, look at this compressor. It can do over 3 times, almost 4 times the amount of capacity at 0 degrees. Same compressor, higher temperature, more capacity. And as you can see with the question Manuel asked earlier, so here's the mass flow. We're colder. And we got 561 pounds per hour of mass flow. That's the refrigerant moving through the system and moving through that compressor, 561 pounds per hour moving through that compressor. But if we look up here at 0 degrees, same condensing temperature, moving over 2,000 pounds per hour through that compressor. It's when I first seen this, I'm like, wow, that's very interesting. So at a higher temperature, it can move more refrigerant and more capacity. And as you can see, that you got a different EER rating for that compressor now. As you start to drop the temperature, it takes an efficiency hit because it takes more work to do that. Higher compression ratio, which we're going to talk about in a little bit. Compression ratio is one of the leading causes for compressor failures. And we're going to talk about compression ratio in a little bit. Let me see. Okay, that's all good, Denzel. Stan, thank you for sharing. Okay, I got a question for Esteban here. Thank you for sharing on the field. We'll find sometime question about tons or horsepower of compressors instead of BTUs on certain condition. BTU is pretty much accurate since some compressors vary efficiency or lower horsepower to reach the same BTU. This is nowadays standard to all brands or still sizing on a horse. 100% BTUs for me. Like there are some old school guys that use horsepower. All compressors that I look at, I talk in BTUs capacity. I could do it in tons as well. There are some that talk in about horsepower, but for me, BTUs is accurate, as you can see here. And we'll look at the next one. Like this is all in BTUs or kilowatts. It could be in watts or kilowatts as well. But BTUs on the compressor. When you talk about horsepower, now 1 horsepower is 12,000 BTUs at specific conditions, these AHRI conditions. When you drop that temperature, you go down to a low temp. Well, now you're not spot on. You could be like, okay, that's 4,000 BTUs or 6,000 BTUs, whatever it is. I know I've been shown how to do it before, like the equation of taking BTUs to horsepower, but with all these different glide refrigerants, different conditions, I just go with BTUs or kilowatts, and people make that. Yeah, so Manuel has another question. With compressors with unloaders, is it possible to get performance charts? Yes. I know Copeland has some, so for example, there are 2-stage compressor it'll give you when it's loaded and unloaded. On 6.4 and 6D compressors, I don't know. That's a great question. I'm going to write that one down. It would be in a percentage wise, but that's a great question. I love it.
Hey, Trevor, I got a follow-up question to that.
Yeah.
So following up from compressors that unload, what about VFD compressors?
Yeah.
Is there a performance charts for those as well?
Yes. Yeah, there are. There are definitely operation envelopes and performance charts. I don't know. I've seen some before, and we can maybe look one up. We can look them up. But the thing is, it's very dynamic with variable speed because it changes the mass flow. So this mass flow is not as, well, it would be steady at those specific conditions, because you can see what'll happen here. Just say I use a compressor that is changing its mass flow, these conditions would be changing with it. So, because you're changing that mass flow. But that's something that we can look up too, because I just been learning quite a bit about variable speed, but I know we have some ZPVs, or I've seen some ZPVs performance charts. Great question. I like that one. Who was that said that?
The variable frequency one, that was me, Matt.
Oh, okay, perfect. Thanks, Matt.
Thanks, Trevor.
Okay, so we'll look that up. So that was the Emerson one. Here's BITZER. So BITZER Software. If you work on BITZER, you need to get this software. They have a B-Spot app as well, and that app is there's lots of great information. And this is kind of what it looks like. It's a little bit different than the Emerson one, but here's the information you want to put in, like what compressor model you want, what refrigerant it is, what your SST and SDT, so your evaporator condensing. And then with this one here, there's buttons up here, so it's always use this play button. When I first started learning how to use this one, I didn't really know that I had to use the play button. So you press the play button, and then over here is your performance chart, and we'll go through that. So in the top here is your evaporator, so minus 20 C all the way up to plus 50 C. And then here's our condensing, minus 20 C up to 0 C. Okay. And then the last is the legend. So here's the legend. So here's our W for cooling capacity. Right there's cooling capacity. So here QU is our evaporator capacity. See, right at this point, it's the same. But if you change certain conditions, say your return gas temperature, it could change this here. So that's why it's important to understand how different system conditions can change how that compressor operates. These are power in kilowatts, then I is for your amps. And as you can see, condenser capacity here. So they got a little bit more. You got EER, then you got your mass flow right here. So M for your mass flow. And you see how the mass flow starts to change as you go colder. And then what else do we have? Operating mode. And in this one here, they have the discharge temperature, discharge gas temperature without cooling. So it's pretty awesome to have that information, because you need to understand, and that's a point as a technician you need to take all the time. Suction gas temperature and discharge gas temperature. Because if you're working on a parallel rack or a multiple compressor application, and you have all the temperature, return gas temperature, because they're all piped together, they should all be similar. And then all the discharge gas ones should be close to the same. And it doesn't matter if you have like a 2 and a 4, or a 2D and a 4D. They should be close. It should be close in that discharge temperature and that suction temperature. But if you go to a compressor and it's way higher, you probably got something potentially wrong with that compressor. You could have maybe bad valves, potentially busted suction read. It could be a few different things, but it's important to understand that, because if your compressor is running hot and you have your proper conditions and you put it in there and just say, well, it should be running a discharge temp of 24 Celsius, but you're running 40 Celsius or 35 Celsius. What is going on? Why is that temperature so high? Any other question? Okay, let's keep going here. I see Manuel got a question there. We'll get to that. So I'm going to do a quick demo here. So let's share, new share. I think this is a new share. So let's go here. So here's the BITZER software, kind of like what I just showed you, just kind of give you an idea on how to get to the performance chart. So you can pick the refrigerants here. You can pick compressors here. You can actually put your cooling capacities if you want. What you want to do right down here, if you want to change the units. So if you want to go from metric to imperial, you can do that just like that. And it'll turn over. Then you can just pick whatever. I'm just going to use CO2 because I really like CO2 refrigerant. Go into a compressor model. Look, this says it's not UL approved, or maybe it is, but you need to look into it. So I'm just going to pick this compressor here. First step, press play here. Gives you lots of great information. They give these manufacturers are really good at giving information out. It just takes a little bit to learn how to get to it. But the performance chart is right here. So when you click on this one here, this is going to give you their performance chart. And all you have to do is press play again. And so here it is. So this kind of gives you the information at these conditions here, -5 Fahrenheit, 30 degrees Fahrenheit condensing. This compressor is going to do 226,000 BTUs. It's going to run at 13.71 amps. It's going to use 9.33 power. So this is, as a technician, will you use this every day? No, you're not going to use this really every day. But when you're finding an issue with inside a compressor or a system, anything that happens in a system affects the compressor. This is why you really need to understand compressors. A TX valve starts to malfunction. You start to get a plugged condenser, you get a plugged evaporator, whatever it is, it always goes back to the compressor, and you can tell signs at the compressor. And when you get into the performance chart, it gives you a better understanding of what is going on. And we'll talk about that in a few minutes as well. But here it is. This is for this specific compressor, this model compressor right here with these conditions. And here you can change your values if you want to change them. So instead of doing 15 steps, you can do 10, press play again, and then it'll change how the steps go, okay? Just to make it more customized to get exactly how that compressor you're working on is, to really pinpoint what it is, the capacity, and well, all the information, I guess. Okay, so that is that one. Let's go up to Copeland now. So Copeland, this is a software. You can use product selection software, which is a software you can download. I'll show you in a second, or you can use their Copeland mobile desktop app. If you are in Europe, you will use Navigation 8, I believe, or Select 8. It's called Copeland Select 8, and it's a similar. It's a similar software. I actually like that a lot more, but than product selection software. But we're going to go through this one. So this is Copeland Mobile. You can have this actually on your phone. I got a compressor here. This is the one that we talked about earlier. You want to make sure you pick your frequency, you pick your refrigerant, and then you pick one of the compressors. So this one's a low temp, low condensing. I don't think there's a difference in between those ones. But you want to go to performance. There's a lot of other stuff in here. I'm not going to go through in here. And then you go to full performance. One thing about dynamic performance, if I get in there, if you calculate stuff here in dynamic performance, it gives you your discharge temperature. See, we're running real hot there. 277 is real hot on that discharge. Okay, and that would be 6 inches from the discharge line down to. But if we get into the performance chart here, this is what it looks like. Let's get into it. So the blue area, once again, you need demand cooling. Okay, so if I'm running 115 Fahrenheit and -20, I need some sort of demand cooling, low superheat or demand cooling. You need to go to this bulletin here and look it up. It's going to explain in the bulletin depending on the refrigerant and where you're at with that operation envelope, and in that performance chart here, you may need some sort of cooling. Head cooling fan, injection like demand cooling, or liquid injection, whatever type of compressor it is, or injection. So that's suction cooling to cool the motor of that compressor, or it's going to overheat. Any questions so far? One of the big things that what I've learned about these compressors over time is that at different conditions, you can get the same capacity, but or different capacity with different conditions. So right here, if I'm running at -10 15 PSI, I'm running at 94,000 BTUs. And this is at 316 PSI. But if my compressor is running at 375 PSI, I'm only going to get 76,000 BTUs. That's almost 20,000 BTUs less. Now, how does that affect the system? You need to think about that. Or if you're supposed to be running at 0 degrees, we'll say right here. So this is the top end of this compressor. So it's 23 PSI, and we'll say at 90, we get 170,000 BTUs. But we're not running at 23. We have a big pressure drop in the suction line. We'll say 10 PSI, oh no, this one's 11 PSI. So 11 PSI pressure, that's too high. It's like if you have a suction filter in there and it's plugged, or if that line size is incorrect. I've seen this before where whoever sized it wrong, the suction line. But if you have that drop all the way down from 90, so you have 178,000 BTU, now all of a sudden, look at the capacity. Now you get to a job site, and all of a sudden, you're supposed to be getting 178,000 BTUs out of that compressor. Now we're only getting 119,000 BTUs. Not getting the mass flow. So now we're not cooling that compressor too, because that mass flow is pulling in the gas, which cools the compressor as well. So this is interesting about the dynamics of compressors and understanding each compressor, because it took me a long time to realize that each compressor has different performance chart. They work differently. Cooling's different. So that's that one. So another one is Carlisle. I seen Carlisle up there. I pulled this one out. You can download their software, Carwin software, selection software. What you need to do is click on run calculations, right? When you get your compressor, you get your refrigerants, you get the model of the compressor, you put in your voltage. And then if you click this button right here, the rating data, it'll bring you all the way down. And so now you can play with the Carlisle compressor. So you can change the return gas or the fixed superheat, or your discharge and your suction. This does take time. Sometimes you have to do this outside of your work hours, but if you want to learn, you want to become the best technician out there or really understand compressors, you got to take the time to learn this stuff. And so here you go. Here's the capacity here, flow rate, mass flow rate. It's running a little bit slow here. Here's your saturated suction temperature. Here's your saturated condensing temperature. And as you can see, I didn't talk about this earlier, like at 100 Fahrenheit condensing, could be Celsius, and all of a sudden you drop that condensing, look at how much the capacity increases. So reducing that compression ratio. You'll want to increase your suction and reduce your head pressure as much as possible to get more efficiency out of that compressor. There are limitations. John, so will you please share? Yes, I'll share the apps. I'll send an email out to everyone, kind of all the different softwares I use, because you need to use these. You need to have them. You need to be sharing them with other people and let them know that there's these softwares out there from these different compressor manufacturers. There's another one. Not many people clicked on Bach, but Bach has really good software as well here that you can dive right into them. Other manufacturers too, Danfoss has it. You just got to take the time to look that stuff up. Okay, let's go back here. Share. We're going to share. Screen 2. Questions? Any questions? Did I hear someone there? Okay. Let's talk about compression ratio. This is super important because I talked about it earlier about compression ratio. We've seen the charts there. We've seen how the compression ratio can change, right? And there's different things that cause it. But what is compression? Anyone know? Can you explain how compression ratio works? Oh, I just put it up there. So hit the button a little fast. So it's the absolute discharge over the absolute suction. Does anyone know how to get absolute? How about throw it in the chat?
multiply your, sorry, not multiply, add 14.7 or 15 to
Yeah,
your discharge pressure and your suction pressure.
exactly. So if you're talking in PSI, yes, add 14.7 or 15 valve, put it in there 15, which is great. It makes it quicker to do. If you're talking in bar, you add 1 bar because a bar is 14.5. And atmospheric is 14.7. So you would add a bar for an example. So Imperial units, I got an example here. Your gauges say 275 PSI, you add 15 PSI, you get 290 PSI A because it's absolute now. And suction would be 55 plus 15 PSI, which equals 70 PSI A, which gives you a 4-to-1 compression ratio. And it's important to understand this because the higher compression ratio, the more work, the more heat, and a lot of the times you're not satisfying your evaporator or your cooling capacity or your cooling load that you need to satisfy. And many things can affect compression ratio, and we'll talk about that in a minute. If you're in metric units, for this example, 19 bar plus 1, 20 bar, and then that's on your discharge, your suction, 4 bar plus 1. So it's 4-to-1 compression ratio. And you need to understand this as well because when you have a high compression ratio, a lot of heat, but if you have a really low compression ratio, you can run into issues as well. Because if you have a low compression ratio, you still need to have, be compressed, pull gas in and compress gas. You don't see this too often. Usually there's something going on with the compressor itself. Like damaged valves, you're not pumping anything at all. So if you have a busted discharge and suction reads and you're just got your gauges on it and it's kind of like equal, and sometimes maybe you have 2 or 3 busted valves that have 4 or 6 cylinders. So if you have 6 cylinders and you have 3 busted and you have your gauges on, your compression ratio is going to be a lot lower. So these are the things you got to think about. And that's why if you use a performance chart and you looked and you had your gauges on there and you're like, wow, I should be pumping this amount of refrigerant. These should be my pressures, but my pressures are here. And you'll be able to see that. You'll probably be able to hear it as well. As a technician, you get to use your eyes, you got to use your ears. Very important to do that. Okay, here's a quick example. So you're on a service call. The design conditions over here for this compressor, 3DF3. Design conditions are 90 Fahrenheit and minus 20. So 90 Fahrenheit minus 20 right here. So this is where this design system should be. But when you show up, you put your gauges on, you got a 10 PSI, which is exactly what this would be, but you have a discharge of 213. Okay, what should it be? Let's see in the chart. For the design condition, what should that pressure be? Design condition, this is your customer. What should the pressure be at 90 Fahrenheit? Just throw it in the chat, anyone. They remember. So what should that condensing pressure be, or your discharge pressure? Ooh, mouse is all over the place. Anybody know? Anybody want to take a stab at it? So at 90 Fahrenheit condensing, what should the pressure be? Anybody want a hint? Anybody want to take a stab at it now? Oh, thank you, Craig. I appreciate it, Craig. 182. So at design condition, that compressor should be running at 182 PSI. But you get there and it's running at 213. Okay, what kind of issues will that lead? Is there an issue? You guys can throw in the chat. Is there an issue? Craig, what do you think? Is there an issue? And anybody can unmute and we can have a conversation about this. Is there an issue? Poor airflow at the condenser. There you go. What could be causing this? Okay, John, excellent. Poor airflow at the condenser based on design and probability. Probably, yeah. What is the ambient temp? That's another good thing. So what effects does it have on the compressor, right? So great thing. So as we're talking about here, we're supposed to be running at a 90 condensing, but we're running at 100 condensing. I'm saying, yeah, ambient could be one, could be dirty condenser, but this is what that compressor should be performing at. Okay, we should be getting 47,400 BTUs out of this compressor at these conditions, minus 20, 90, 10 PSI and 182 PSI. Right, this should be the mass flow, 606. This is not a big deal right at this point. Our amps should be 24.1 amps. Okay, here's our power, 6,800 watts. Okay, but this is what's happening right now. So now I got higher condensing, so higher pressure. I have higher amps, right? I got higher temperature coming back. So when you look at this, there's something going on. And with this case and with this compressor, for example, what else happened when now we're running into a higher temperature? What else happened? Besides, we got a higher discharge, we got a higher amps, we got a higher lower mass flow. What else just happened when we went from 90 to 100 with this specific compressor? Does anybody know? Compression ratio definitely increased, so we're doing more heat. Capacity went down, yeah. Higher discharge temperature, yeah. What else? There's something else that happened when we went up to there. So we went from a compressor that may not have needed demand cooling or low superheat to a condition where now you need some sort of cooling, right? So now you're running that compressor hotter. Manuel put it in there too, higher discharge temperatures, right? So now we get in a zone where you need maybe a head cooling fan, injection, refrigerant injection. And so this is why I think it's important to kind of at least understand and know that specific compressor you're working on. Because if you go out as a technician and you put your gauges on and you look at it and you don't really understand what those pressures should be, you can go back to this chart and get an idea, because these manufacturers spend millions and millions of dollars on testing them, all these large manufacturers, and building these charts. So they're pretty accurate. So as a technician, if you put your gauges on, it gives you an idea of what is happening. Then you got to go figure it out. You still have to go figure out what is happening. So here we go. I know John put some stuff in there too. So causes of that high compression ratio, that high side issue, dirty condenser, issue with a fan, bad water valve, recirculating air. These are the things that now as a technician, you need to think about when you get to that service call and you're running higher condenser, higher condensing pressure or discharge pressure. And then on the low side, which I'll add to, it's that pressure drop in that suction line. So you got your gauges on your compressor, you got a plug filter dryer, you got an issue with your TX valve, undercharge, frozen coil, evaporator coil, low load situation. So these are the things that you need to think about. And I really think starting using compressor charts over time will give you a different look, especially as a technician, because it totally changed my outlook, because I've done tons of field support on compressors, and understanding these different charts and how the dynamics are affected when those pressures and temperatures change. When the pressures change, that suction pressure, that discharge pressure changes, it totally changes the dynamics of that compressor. So something very interesting that I find. Any questions on that? Any questions? I know we're getting near to the end here. I really want to respect your time because I could talk days on this stuff. I love it. Mobile apps that you need. If you don't have these apps, and I'll send it in an email to everyone that's here, is you need Emerson AE Bulletin. So you'll have those operation envelopes in there. You need to have the BITZER B-Spot app because you can get in there and get all the instruction manuals from BITZER. Danfoss Ref Tools, you need that app. They got great calculators in there. They got all of the manuals you can get in there, installation, operating manuals. COPO Mobile, I've actually shown you that earlier today. So there's a lot of value in these apps to use and troubleshoot as a technician in the field. Or if you're an instructor, you should be using this in the classroom to practice with them. Give them examples, suction, discharge, and maybe the amps and the volts, and they go plug that into the app and ask them some questions on, well, what should the mass flow be with those specific conditions? What should the discharge temperature be? And this is how you got to start thinking. And I thinking, because I didn't do this, to be honest, when I was in the field, I did not do this. I just used, I had a PT chart and kind of look where the SST was. Oh, well, it should be minus 25. I'm running at 40 box. What's the TD across the coil? If it's 10 or if it's 8, you know what I mean? But using these charts give you so much more understanding of the compressor, I believe. And it's going to take time to understand it more and more. Okay, educational resources. You need to learn more from lots of different areas. I still continue to work with lots of different people, trying to get better so I can share more knowledge with all of you. So VAC School, Vortex, Bitex, HVAC Know-It-All, HVACR videos, R744 CO2. So check them out if you're in natural refrigerants. Commercial refrigeration is going natural refrigerants. So you need to start learning it now. You're going to see propane, CO2. It's already happening. It's just going to be more and more. So start learning that stuff. I'm going to be doing more and more trainings on those refrigerants. I love talking CO2 and talking natural. So you're going to see more and more events coming from me in that space. Tool Shed, those guys, Jerry Rollins, Eddie McFarland, talking about promoting the trades, helping your technician, helping you mindset, what to do, when your truck rolls, things like that. Great videos. I know there's a lot of content out there, but these are the people that I follow and get information from. The middle book, down below, Commercial Refrigeration by Dick Wirtz. I'm still reading that book. I got it right here. I find if you're new to the industry, that's a great book to start learning out of. The other one that I didn't get to show you, I'm actually going to pull it up. I got it right here on my shelf. Is this one here? This is free online. This is the Copeland manuals. It's old, it hasn't been updated since the 90s, but that information is golden. That's what I learned at refrigeration from. You need to learn and just continue to learn. Invest in yourself. Invest the time to learn a bit more. Okay, let me see. What else do I have? Okay, last question here. So, when was the last time you attended a compressor training program? So, when were you to a compressor class, a Copeland class, BITZER class, Danfoss, Tecumseh class, whatever it is? Less than 3 years ago, plus 3 years, plus 5, or never? Just kind of want to get an idea, because this is something that I'm trying to promote more and get out there. So great job. I think a few more answering. Well, plus 5 and never. I'm going to share the results with everybody too here in a second. And Paul, I think that's everybody. So here's the results. Couple people less than 3 years ago, fantastic. And if you've taken it before, I see some 5+ years ago, take it again. The people that I've met that have taken compressor classes in their life, they've taken multiple times, because there's things that you just forget over time maybe, or just don't remember, and it gets you back into the zone. I've had dozens and dozens of technicians come and say, and they were in the trade longer than me, and they're like, Trevor, you just got me back on track, and just remembering some of the stuff that I used to know, but over time I just got in the same way, same habits, and just got out of that. So always invest in yourself, learn, try to find more information and learn more, because it's all about learning and getting better. Chris, yes, I'm going to stick the recording on YouTube for sure. I'm going to send everybody here the recording. The COPO manuals are online. I'll send that, how to get to them. Did not see what happens to oil migration on these charts, or is that an unknown? Yeah, so that's going to be, migration is going to happen when that compressor's off and the compressor's colder than the rest of the system, and the refrigerant migrates back to the compressor as a vapor condenses in the oil. So you won't really see that, Walter. So. Thanks, Joel. So I got a 4-week compressor masterclass coming up in February. So I got a waiting list. I should throw this in the chat right now. Let me just throw that in the chat for everybody. So if you want to get on the waiting list, so when I get my dates in February, it's probably going to be the first week. Right here, I'm going to send it to everyone. So if you want to just join the waiting list, there it is. Just click on there. Name, email address, you'll get on the waiting list for it. So I just threw that in the chat. Last thing, am I still sharing here? Yeah, I'm still sharing. Bam, questions. We got 3 minutes left. I'm sorry that I almost went over time. I could keep talking. It's super fun. Definitely, Mark. I'll send you some more. Can we speak about cylinder unloaders in this application? So in the course, I will be. Yeah, I'll have in that 4-week compressor masterclass, this one here. When I get into the semi-hermetic section, we'll talk about unloaders, start unloading. We'll get into digital compressors, variable speed compression. We'll talk about all those different things, get you a good understand as well on the scroll compressors, the different technologies on the scroll compressors, because I see more and more, there's millions of them out there. And I'm sure lots of you work on that as well. So in this course, we'll be talking about all that stuff and really getting into electrics. Like I think electrics is big. I was not very good in the electrics and compressors, and it took me many years. And even now, I'm still getting better. To be honest, I don't feel I'm an expert. I know a lot, then I have a lot to share. But getting into the electrics of compressors and understanding that, because I've changed many compressors that they weren't failed. And so this is the things that we're going to talk about in the program. Mass flow. Kelly got a question. Mass flow. I don't really understand what can be done as a tech. Well, you can't really do anything about the mass flow. That's the amount of volume that compressor is going to move. Okay. But you need to understand how the mass flow works. Because like on a digital compressor, mass flow doesn't change. Variable speed compressor now, the mass flow changed. So you need to think about oil management, oil boost. Cooling of the compressor, if it's running on very, very low load, and that variable speed is running load. And there's different parameters depending on the compressor. Is it an actual variable speed compressor, or is it a fixed compressor with a variable speed put on it? So we'll talk about that in the program as well, Kelly. This is a course online. Yes, Chris, the course is online. It's fully virtual course with assignments, quizzes, and the course is $497 US. So you'll see that when I send you in the waiting list, but that's the cost of it. So there's going to be assignments for field assignments, so things you're going to have to go out and do, and there's going to be quizzes to really get your knowledge up there, to do the work. Because to be honest, you want to get better, you got to do the work. You got to put the time in. That the technicians that I deal with and work with that are experts, they're investing their time during work. But after work, even when they're not getting paid, and I know everybody wants to get paid, and I want to get paid, but if you want to be the best technician out there, you got to be investing your time. So not only during your work hours, but outside your work hours. And that's where I see the best technicians out there. Those guys are spending a few hours a week outside their work hours learning, if it's digital, if it's variable speed, if it's just a new system that they're working on. Understanding things that they may not have really understood before, like DDR valves or hot gas bypass valves and sort valves, whatever it is. It's just getting to understand and learning outside that, and then relearning stuff, going back into those COPO manuals and trying just rereading stuff. Because where I learned so much now by reading my own old books. Like I understand when I read refrigeration now, where for 10 years I was reading refrigeration, to be honest with you, and I kind of knew what they were talking about, but didn't really fully understand. Now when I read something about a heat pump or something about a makeup air or something about a rack or a CO2, I understand the meanings and terminology because I've reviewed it. So I highly recommend invest in yourself. Continue to do that, okay? Okay, we're 6:01. I want to thank everybody for attending. I hope you learned one or two things from this session, and I hope to see you at the next session. Okay, thank you so much, everyone.